Okay, so now if we look at this, we can change the size of our sun right here. And when we change just the size of our sun and we increase the mass, how much stuff, so we're adding more and more stuff to it, we can start to see where the gravity changes. That's the arrows. It starts to pull more on the earth. Let's see how changing the gravity changes the way that the earth interacts. Well, if I make one path at fast forward, I'm going to take away my velocity. I'm going to hit play. We could see that the earth takes a pretty circular orbit, just like it's doing right now with our sun. But if after one orbit or one revolution around 365 days, if I move this thing to 1.5 times and the gravity increases and the sun's larger now, what do you think is going to happen to the earth as it goes around the sun? How is it going to change the orbit? Well, let's see. Oh, goodness. Look at that. The gravity is way intense right now. These arrows are way big. And if you look at this thing, look at how close it is to the sun. It took a complete pull into the sun, and now it's speeding up faster. And you could see the velocities changed. Now the velocity got shorter, which means it's going slower. But as it comes back around, it begins to slingshot. And as it does, look at how that velocity increases and it goes faster. Wouldn't that be weird? And then it starts to slow down and the gravity decreases. But wait a second. If I increase the mass, look at how it's different right here and right here. Distance also has a thing. Before we get to that, I want you to answer the question, how does changing the mass of one object affect the gravity? Well, hopefully you can see it affects it by increasing the blue. How does it affect the revolution? Well, it changes the elliptical orbit.